Today we're going to begin our first lesson on objects and classes. This will be the theory section of object-oriented programming, and on the next video we'll jump into the implementation, so stay tuned. So what is object-oriented programming? Simply put, it's a way of organizing code into objects rather than logic and functions. So you're used to writing your code in methods or inside the main method. And that's not what we're doing here. We are trying to organize our codes into objects. And looking at the next slide, we have, so this would be, we would see some real life objects. Now, I want you to think of objects. Think of any object you can think of, like a cell phone, I don't know, a house, even a person is an object. Anything you can touch, you can feel, you can touch or feel, you can even think of is actually an object. And an example would be a human down here. So a human, you know that a human can do things, right? They can walk, they can speak, they can do whatever it is that they do. If you would have to express that as in codes, like in Java, you would express that as methods of the human. And don't worry if you don't understand. For now, we will explain that more into detail later on. And the attributes of that person would be the color of their eye, or the color of their skin, or how tall they are, or the weight, anything. And another example would be a car. A car can start, it can stop, it can accelerate, etc. And it has attributes like I don't know, the capacity, the engine capacity, or it can have the top speed. That would be an attribute of the car, the color of the car, and stuff like that. And then here we would have a cell phone. The attributes would be something like the megapixel of the camera, say the camera quality. You can what else? The Android version, or if it's iOS, the version of that iOS. I've never used iOS before. I don't know if that's how it works, but pretty sure it does. And yeah, so those would be the attributes, and the methods of that cell phone would be calling, or whatever it is the cell phone can do, taking a picture, playing music, things like that. An example with regards to humans is all these labels that you see here. So you see a human down here, and you see eye color here, and height and weight. Those are the attributes of this human class. So if we'd express that as Java code, I mean, this is not actual valid Java code, but it's close. So here we have a class. We would have to write a class, and then we would have the human, the name human, or the name of the class that we're trying to express, or the name of the actual object. Not the actual object, but the name of the object. So that's a human. And then here we would have the attributes: eye color, body weight, and body height, as we can see here. Those are the attributes as we've explained. And the things that a human can do, those we would express as methods. So you would have talk, you'd have walk, and etc. Whatever it is that we're going to use inside our program. So we're not going to explain things. We're not going to create methods for things that a human can do, but we're not going to use them in the program anyway. So we'll work with what we are going to use. So they can talk, they can walk, etc. And yeah, that's it. So these are the attributes, these are the methods. So you would write them: public static void talk, and so on. And here, to express the eye color of the person, you would say either red or blue or whatever. So you would store that in a string, right? And the body weight, you would store that in a double, and the body height, you would do the same. You'd store it in a double. So that's an example of an object and how it is. So here, this is actually a blueprint. So what a class is not an object. A class is a blueprint or an object. So this is what every human has. Every human has an eye color. Every human has a body weight, a body height. Every human can talk, they can walk, and stuff like that. And then you can call your objects. You can instantiate your objects. Actually, not call them. You can instantiate them, and you can instantiate many different objects and give them the actual values, as in what eye color you want that person to have, what body weight you want that person to have. But we'll talk about that when we get to the implementation section of this objects and classes section. Now, there are 4 pillars of object-oriented programming. You get encapsulation, inheritance, polymorphism, and abstraction. Now, encapsulation would refer to hiding information. So if you go back to this slide here, these parts, this section, the attribute section, we would set these to private, right? We'd set these to private, and if they are private, meaning that they can only be accessed by this class. And then we would create what we call getters and setters in order to set these colors to whatever it is, to set these attributes to whatever it is that we want. But we're not going to get into that as of now because that's going to be confusing. So that's what encapsulation refers to. It's about hiding information. And then inheritance would be a class inherits attributes, inherits some behaviors from the other class. So if we have a human here, we can have another one called, say we'll call that class student. A student is a human, so it will have an eye color, a body weight, a body height. It will be able to talk and walk, but it'll also have its own things that will be specific to student. So that would be inheriting from the human class, but also we'll get into that later on. Polymorphism is advanced as of now, and also abstraction. So we'll get into that later. And here we get some detailed a little bit of explanation of each pillar of object-oriented programming. So we, as you can see here, we see that encapsulation refers to hiding data and using getters and setters instead for security purposes, and the data members or attributes should be hidden. And in polymorphism, the method actually takes on many forms. So in the class in which, so before I can explain this, I want to explain inheritance. So in inheritance, the class inherits attributes and methods from another class. So as we can see, we spoke about that recently, and the class where the other inherits from is called a superclass. So the human class would be a superclass in this instance, and the subclass would be the student. And if we go back to this polymorphism, we'll see that the method from the superclass that behaves a little bit different in the subclass, so you change it a bit. Now that's advanced. We don't want to get into that as of now. We'll get into that later on. And abstraction is also advanced. It talks about hiding unnecessary information. We only show what we want to show to people, or like outside of the class. So we hide the unnecessary information, we show what is necessary. So yeah, that's basically it. And now we can move on to the implementation section of the object-oriented programming section.